right, so we're going to derive the formula for the exterior angle part of polygons. So here's my polygon. All right, so we talked about how the sum of the interior angles is the number of sides minus 2, that tells you the number of triangles, and then multiply that by 180 degrees. That's the interior. Each interior angle, so here's one. Hey, buddy. All right, there's an interior angle. The interior angles are obviously inside, and exterior angles are formed by extending a side. That's the only way you can do it. So this is an exterior angle. This is not. I hope you see the difference. You form exterior angles by extending a side. Like that. Okay? So I'm going to do more of those in a second. But first, I want to point out that the interior angle and the exterior angle together form, and hopefully your head just said, a linear pair. Yes, they form a linear pair, which means that the sum of an interior and exterior angle is 180. They're supplementary angles, which will be helpful later. But right now, not such a big deal. All right, this is not a regular polygon. And the first thing we're going to do is draw all the exterior angles. I'm going to go the same direction around the whole time while I do these. So just extending a side to form an exterior angle. All right, last one. Okay, so here are exterior angles. And what we're going to do is actually measure them with a protractor and see how many degrees each of them are. So remember, you use the little plus sign part at the bottom, line up the bottom line with your angle, plus sign on the vertex, and follow the line up. So this looks like it is 70 degrees. All right, and I'm going to do that for each one. So if I do this one, just remember we're measuring the smaller angle, the exterior angle. So we want to look at the smaller numbers. This looks like 57 degrees. All right, this one, 55 degrees. Let's check this one. Maybe 56. Ooh, I gotta walk around to do this. This one, 70. And the last one, I'm actually gonna do it like this. I feel like I'm gonna sneeze, so if I sneeze on this little video, sorry. Now we're gonna be looking at the bottom numbers because we're using this small angle and they're on the bottom. So if I extend this up, looks like 55 or 56. I'll go with 56 for fun. Okay. So there's the exterior angles, and obviously this is an irregular polygon because these are not all the same as each other, because the interior angles wouldn't be either. So I'm just going to add those up. And they equal 364. Now obviously 364 is a super random number, but I'm also a human using a marker. So what do you think these would have added up to if I was extremely accurate? 360. And that's true for every single exterior angle. So if you do this exactly perfectly and you measure it exactly perfectly, the exterior angles are always equal to 360 degrees. So the sum of the exterior angles of a convex polygon is just 360. It doesn't even require any math. It's just 360 degrees every time. So if I say, what is the sum of the exterior angles of a 50gon? The answer is 360. If I say, what is the sum of the exterior angles of a 100gon? 360. What's the sum of the exterior angles of, well, I should be more specific. These are only if the shapes are regular. Well, no, that's all of them. Sorry, it's early. So the sum of the exterior angles of every convex polygon, meaning the sides are puffed out, nothing's caving in, is always 360. Doesn't matter how many sides. If you want to know if it's regular, meaning all the sides and all the angles are the same, and you want to know the measure of each exterior angle, you're just going to take the 360 and divide it by the number of sides. You should make those look important too. Okay? So what's the measure of each exterior angle of an octagon? Well, first we need to know what an octagon is. It is an 8-sided polygon. So we're going to do 360 divided by 8. And that equals 45 degrees. So each one would be 45 degrees. Okay? So bottom line, exterior angles. Sum of the exterior angles is 360. Each one, you just divide that by the number of sides. And just for a brief recap, if the angles on the outside or the interior angles have their exterior angle drawn, they are a linear pair. So if this is 70, what would this be? 180 minus 70. 55, so we would do 180 minus 55. 56, which we know these are all, or 4 of them are off by 1, so we're just going to leave it. So this would be 124, 110, 124, and 123. All right, and now if we had measured exactly, these would add up to the sum of the interior angles, which we talked about in the other video. The other video says you need to know the number of sides, 1, 2, 3, 4, 5, 6. N equals 6. Interior angles, N minus 2 times 180. So 6 minus 2 times 180. 4 times 180. This has 720 degrees. That's the sum of the interior angles. The each interior angle, we can't actually do this one we measured, but if it was regular, we would do 720 divided by 6. That'll give you the degrees if it's regular. 120 degrees each. Exterior angle sum, 80. What am I writing? 360. And each exterior would be 360 divided by 6. 60 degrees. Okay, so that's a little summary, and I'm sorry if I'm rambling. I feel kind of sleepy today. So I hope that made sense in a little tiny review of everything. And you should be ready to go to the other videos where we do problems with using these formulas instead of just deriving them.